Howdy 7th grade, I'm glad to be back with you on the videos. Today we are going to learn about the distributive property, which is a big fancy word for something that's not actually that hard. I want to talk to you about buying clothes, really. What we're going to talk about today. There's a couple different ways to do that. Let's say I took 10 of the people in your class shopping. I'm going to take 10 kids shopping. And each of y'all are going to get, each doesn't have a G in it, each, there we go, get a $10 shirt and a $25 sweater. How much did I spend? So I hope this isn't a terribly hard problem for us. We've probably seen much harder problems than this. I just want to point out to y'all that there's two different ways to do this. We're going to have two methods, method 1 and method 2. So I'm going to make sure, as I go through this, I want to think about my problem. I know there's 10 kids. Each get $10 shirt, $25 sweaters. That's what's important. Method 1, I'm going to think about how much per kid. To figure that out, each kid gets 10 plus 25. And then I want to multiply by the 25, or by the 10 kids, yes? Then I multiply by 10 kids. Because each kid's getting one of those, and I end up getting that it is 10 times 10 plus 25. And that's one way of getting my answer. The other way of getting my answer over here is I'm going to think how much per item. So what I'm going to do, I know that each pair of shirts, or each shirt is $10. I'm getting 10 of those, so it would be 10 times $10. And I know that I need 10 sweatpants, and each of those cost $25, so it'd be 10 times 25. And now that I have that, I could solve this, and I'd get my answer. But looking at this, I've got two different things that are supposed to give me my answer, and one of them is here, and the other is here, and I don't know which one I should use. The good news is these are the same. So they're the same. If you're following along at home and really want to know the answer, it'd be 350. We're not really going to get into that right now. $350. That's a lot of money. But all of these are the same, both ways of writing it. So what that means is we have what we call our distributive property. And I'm going to write it with letters first, and then we'll explain it, and then we'll do it with some numbers. The distributive property says if I have A times B plus C, that's equal to A times B plus A times C. I know that's really weird, but we're going to try it with some numbers. The first numbers I'm going to use are going to be 3 times 4 plus 5. That should be equal to C. A and B right here would be 3 times 4 plus 3 times 5. If you didn't know, the word distribute means to spread out. So all that's happening is this 3 is spreading itself out inside the parentheses. So we'll try one more of these, and I'll show you how I like to write it. So I have 6 times 7 plus 10. I can take this 6 and distribute it into my parentheses. I'd end up with 6 times 7. I keep my plus sign. Then I have 6 times 10 from the other arrow. Just like that, I have distributed. I want to show you all one more. If I have 15 times 12 plus 20, that would equal, that should not be there, that needs to be a minus. 15 times 12 minus 20, that's going to equal 15 times 12, because the 15 goes into the 12. I keep my minus sign here, so I end up with minus, and then I bring my 15 into the 20. That'd be 15 times 20. So all that's happening here is we are distributing things out. I know a lot of us are probably thinking, why does this matter? So I want to show you why it matters. Let's get a new color. I like using as many as I can. If I have something like 6 times x plus 3, I can't really do anything with this. I know up above I could have just added these and I'd be fine, but I can't do that here because I don't know what x is. So instead what I'm going to do is I'm going to distribute my 6 in. Right here I have 6 times x. I keep my plus sign, then I have my 6 times 3 right there. And that is how I would distribute. Another important thing to be able to do is going to be to factor. This is a little bit different than making a factor tree, but it's basically doing distribution in reverse. So if I say to factor is distribution backwards. What this is going to look like, if I have 6x plus 9, I want to ask myself, what can I take out of both of these? So I'm going to actually do a factor tree of both. 6x is 6 times x, 6 is 3 times 2. I know 9 is 3 times 3. So what I end up with here is 3 times 2 times x plus 3 times 3. And what I want to do when I'm factoring is I want to look for these front numbers. So look for numbers that are the same, and then I take them out. So I'm going to remove numbers that are the same. So I have my 3 and 3. They're both there. I'm going to remove them, and they're going to come out to the side. What I have left is 2 times x plus, and what I have left over here is a 3. So I took both of these 3's, and all I did was I moved them right out, and everything that was left went right through there. I'm sorry, I'm drawing through my words. If you don't want to draw those arrows, you might want to avoid that. But all I did was I took the things that were the same and removed them, and left the things that were different, and that is how we factor. I'm going to skip over the order of operations part, because I feel like we've done order of operations several times. What I would like you all to do is make sure you do the practice set, which is A through M. Makes me happy when you do the practice set, and I will see you all tomorrow. Toodaloo.